Hello everyone. Today's lesson is on parametric equations. So far in this unit, we've discussed two different ways of representing situations. One of them is the standard, what we're used to, format, which is the Cartesian format, where we use x's and y's. We've also been working with polar coordinates, r, comma, theta. And so in today's lesson, I'd like to introduce another way to do it. And this is by introducing a third variable, which is the variable t, which represents time. In this way, we're going to use t, but we'll also be using x's and y's. So in a sense, it kind of combines Cartesian coordinates with the concept of time. So there's some advantages to using it, to doing it this way. One of the advantages is that it gives the position or location of a point in time. Second, it also gives the direction which that point is traveling across time. All right, so now let's do a couple of graphs of parametric equations. So you have that x of t equals t squared plus 1, and the y value equals 2 plus t. We're not given a specific domain for t, we're not given a specific set of values for t, so I'm going to just give us -2, -1, 0, 1, and 2 to plug in to our x and our y equations there. And I would suggest that you use these 5 values for t in situations where you're not given a situation for t, which is what we have in the next problem. We're given the set of values for t. So first off, when t is -2, to find what x is when t is -2, we need to substitute -2 in place of t in our x equation. We'll square t and get 4, and plus 1 and get 5. To find out what the y value is, we'll do -2 plus 2, which is 0. Same thing for -1, square it and add 1, and then add 2. For 0, we'll square it and add 1, and then we'll add 2 to it. For 1, we'll square it and add 1, add 2 to it. Square it and add 1, and then add 2 to it. All right, now we know that with parametric equations, we have a position and we have direction. So the order that we graph these matters. So we'll start with the least value of t, which is -2, and then we'll graph that point first. X is 5 and y is 0. So we'll plot that point there. Then the next point would be when t is -1, and that's the ordered pair 2, 1. And then when t is 0, we have 1, 2. So we've got 1, 2. When t is 1, 2, 3. And when t is 2, 5, 4. And so essentially what we have here is we have a sideways parabola. This parabola would continue on in that direction and in this direction. So now we've got the shape. We have a description of the position of our point across time. But next, remember that the direction that the point is traveling is important when you have parametric equations. Our first point was here, then here, then here, then here, then there. So we can see that the point is traveling in this way. And so to indicate that it's traveling that way, I'm going to draw little arrows, a few little arrows on the graph to show that the point is traveling on this path. Now this arrowhead here, remember, doesn't mean that the point is traveling that way. That just means that the shape or position of the graph is going to continue on in that direction if you would go back in time. But as the point travels forward in time, the point would be going like that. All right. Okay, let's see. Yeah, I think you can see that. I'm going to hope so. Alrighty. So now that you saw the top of my head for a little bit, now you can just hear my voice. X of t is 2 cosine t, and y of t is 3 sine t. We're also told that t runs between 0 and up to and including 2 pi. So our t values, the smallest one's going to be 0. Biggest one will be 2 pi. When it gives you a spread of your t values, which appear to be in radian measurement, then I would say go at an interval of pi over 2 units. So start at 0 and then go every pi over 2 units after that. So starting at 0, our next t would be pi over 2, and then pi over 4, and then pi over... Actually, I wasn't even thinking there. If we're going at an interval of pi over 2, we would add pi over 2 to that, and we would get pi. Add pi over 2 to pi, and we get 3 pi over 2. Add pi over 2 to that, and we'd have 2 pi, which is our greatest t value. So we're going to be finding an x and y for each of these 5 times. So when t is 0, find the cosine of 0, multiply it by 2, and that gives us 2. Find the sine of 0, which is 0, times it by 3, and we get 0. When t is pi over 2, the cosine is 1 times 2. The cosine, check that, cosine at pi over 2 is 0, times that by 2, and you'll get 0. The sine at pi over 2 is 1, times that by 3. The cosine at pi is negative 1, times that by 2. The sine at pi is 0, times that by 3. The cosine at 3 pi over 2 is 0, times that by 2. The sine at 3 pi over 2 is negative 1, times that by 3. And the cosine at 2 pi is 1, times that by 2. The sine at 2 pi is 0, times that by 3. So now we've got our points for our graph. So we would start at time 0 and plot 2, 0. All right. Then at time pi over 2, 0, 3. Time pi, time 3 pi over 2. And then at time 2 pi, we're back at 2, 0. And if we went at 5 pi over 2, if it asked us to, we would find that we'd get this point, and then 3 pi, and so forth. We'd end up going around this shape. Now, the shape actually turns out to be an oval shape. And so let's make it curved.